work and to which distance they can like run. So if you want to connect larger number of nodes, uh, you have to use, there are number of connecting devices which are required. Okay, so uh, you have various connecting devices like bridge, switch, router, hub, repeater, or gateways. And the act, we have seen there are different layers. The functioning of the entire network is divided into different layers, and we have, there are different layers which operate, like there are different devices which operate. Sorry. So there are different devices. Just give me 1 minute. I'm sorry. So there are number of devices, bridge, switch, and we've seen there are different layers, and all the devices operate at different layers. Okay, so there are different categories we have seen. This is just a repetition. You have hub or repeater. Again, there are different types of hubs. You have bridge. Again, you have different type of bridges. You have switch, different types of switches, routers, gateways, and they all operate at different layers as seen in the diagram. So we had seen hub. Hub is it's like just like different types, passive hub or active hub, and it acts as a repeater. So basically it will take the data or whatever is the signal, it will just pass through. uh, uh, if it is a passive, it won't regenerate or amplify, it will just pass it. If it is an active hub, it will regenerate or amplify the signal, and then it will be transmitted. So depending upon which type of hub you are using, but it's like a repeater. Repeater will, they operate at like if it is a passive hub, it's like a repeater. It will act at a physical layer, and as seen in the diagram, if it is a active hub, okay, it can be at a data link layer also. So basically, repeaters, they will again there is some like uh, attenuation of the signal. So to eliminate that effect of attenuation of the signal, you need to regenerate the signal, amplify it, and then transmit. So that can be worked. That can be used as a. It can be done at a physical layer with the use of repeater. And the next is physical bridges. Now bridges are like they operate layers. We have seen there are both physical layer and data link layer hubs bridges available. If it is a physical layer device like a passive thing, then you are having, it will just regenerate the signal. It will whatever it is receiving. And if it is a data link layer device, now at data link layer, later on we will see there is a MAC address. Okay, there is a address which is given. You have a network interface card. So on that network interface card, there is a address which is given, which is called as a MAC address. So that MAC address or physical address. Okay, so that can be checked, and accordingly the frames can be forwarded. At a link layer, the data unit which is used is called as frames. At physical layer, you use only the raw data bits, that is zeros and ones. But at data link layer, you talk in terms of frames. So the frames will be transmitted, and these frames will have a source address and the destination address. So whichever is the transmitter, that source address, source MAC address will be included in the frame, and where that particular frame is to be delivered. So that receiver MAC address will be also contained in that particular frame. So at data link layer, when the bridge acts as a data link layer device, it will check the destination address, and according to the destination address, it will forward that particular frame. Okay, so that decision is there, and that how the decision is taken. Whatever are the connected devices, for those connected devices, there is a routing table maintained. Okay, so basically there is a that the bridge can do the filtering. Okay, whatever are the connected devices, it will check whether that particular destination address is mapping or it is there present in that routing table, and accordingly it will take the decision of forwarding of the frames. So here, when it acts as a data link layer device, it will check the source and the destination address. So it has a table, it's called as a routing table, which is used in filtering decisions. So it can check the destination address of the frame and decide whether the frame has to be forwarded or dropped. Means if the destination address is there in the table existing, means it is connected to that device, it will forward it. Whether once that particular destination device has received that particular frame, then it will decide to drop it. Or if the frame is to be forwarded, the decision must specify to which port. Later on, we will see there are different like port addresses there. There is IP address. There are different kind of addresses which are used in the networking. So a bridge has a table that maps the address to ports. So it will limit or filter traffic, keeping local traffic local, yet allow connectivity to other parts, segments. That means there are actually, we have seen that how bridges are used to connect actually different LANs. You have one LAN connected to different LAN, which you want to expand. So this is one LAN, this is another LAN. Okay, and you are connecting these two LANs through bridge. Now this bridge will have different ports. Okay, so which port, which particular address is connected to which particular port. Okay, so say for example, these are two devices. So these two devices will have this MAC addresses are there. So these two MAC addresses are connected to port 1. These two are connected to port 2. So which is connected to port 1 and which is connected to port 2, that will be entered in the table. And accordingly, whenever a frame is arrived, okay, at say for example at port 1, this particular PC, this is communicating with this PC. Okay, that means it has to transmit from port 1 to port 2. So it will check the MAC address and it will check the port entry, and accordingly the whatever frame is received, that will be transmitted to the port which is connected to or which is having that particular address. So basically it will do the filtering and destination address will be checked. So how bridges work? Bridges work at the MAC layer. We have seen routing table is built to record the segment number of the address. If the destination address is in the same segment as the source address, it will stop transmitting, otherwise forward to the other segment. That means whether basically it will check this is segment 1, this is segment 2. If it is in the same packet, if it is in the in the same LAN, okay, then within this LAN it will be transmitted. Or if it has to pass through one port to this another, like one LAN to another LAN, the decision will be taken whether that particular frame has to be transmitted to this LAN or not. Okay, so forwarding of the frame to another LAN will be taken. Okay, it will be taken will be done only when it will check the address. If the address is there in this particular LAN only, it will be transmitted or it will not be forwarded to this LAN. So it is there is a filtering done. So basically, it won't just pass on to all the connected devices, pass on the frame. Okay, so this is the frame. Here you can see this is in same LAN. So it won't pass through the bridge. Okay, it can be transmitted within the LAN from one device to another device because the destination address lies in the same segment. It lies in the same LAN. So it will check the address. This particular bridge is going to check the destination MAC address and accordingly it will pass the frame. Okay. Here you can see here in this case, suppose the destination address is for G. Then this bridge will pass the frame to this next segment, that is to this particular LAN, and accordingly it will be transmitting it to this G. But if the destination address is for D, it won't pass through the bridge and it won't be transmitted to this, though they are connected in the network. Okay, so there are again different types. There is a transparent bridge, something like it is unaware whether the two LANs are connected through bridge or not. It's like they are there in one LAN only. They are all are connected through uh, they are in the same network. So like that, the frames are transmitted. So basically function of bridge is to filter. Okay, so within the same segment, it won't pass. It will transmit to the directly, it can directly go to this particular D if the destination address lies in the same segment or same LAN. But if the destination address belongs to other network or other LAN, bridge will pass, it will pass it to the proper destination address and then only it will discard the field. So characteristics is like what it does is routing table. It contains one entry per station of the network to which bridge is connected, and this is used to determine the network of the destination station of the received packet. So routing table helps in finding the destination. Filtering is it will allow those packets destined to the remote network. We have just seen, and packets are filtered with respect to their destination and multicast addresses. So what is multicast address, what is destination like MAC addresses, you will learn when we will be seeing the data link layer. Forwarding is like passing the packet from one network to another. So here we have seen this is forwarding. So passing the packet or passing the frame from one network to another network. Learning algorithm, the process by which the bridge learns how to reach these stations on the internet. So there are a number of algorithms which are used. Types of bridges: transparent bridge or source routing bridge. Transparent, also called as learning bridge, it builds a table of MAC addresses as the frame arrives. Ethernet networks use transparent bridges, and the duties or the functions is the filtering of the frames, forwarding or blocking of the frames. And source routing bridge is like it is using the token ring. Each station should determine the route to the destination when it wants to send a frame, and therefore includes the route information in the header of the frame. So frame will contain all the information, what is the destination address, how it should be routed. Addresses of these bridges are included in the frame, and frames contain not only the source and destination address but also the bridge addresses. So that is the source routing bridge. So these are different algorithms which will be used accordingly. The packets will be routed. Advantages: they extend the physical network. We have already seen there is LAN 1, there is LAN 2. So LAN 1 can be connected to LAN 2 using the bridge. So you are extending the actual already existing uh, network. They will reduce the network traffic with minor segmentation. There are segments we have already seen. It separates two networks, like these two separate networks are connected. So there is a decision making at the bridge whether to transmit the packet to the second segment or not. So it is going to reduce the network traffic. It is just not going to pass all the packets, all the frames to the other network. Okay? So it is going to reduce the network traffic with minor segmentation. It creates separate collision domains. We will see later on, you will learn what is the collision domain. Collision domain means when the packet is transmitted to number of It's like broadcasted. Okay, given to in respect of the destination address, the packet will be given to all the uh, devices which are connected in that network. And in that case, there can be a collision. So bridges reduce the collisions because they have that segmentation. They connect different architectures. Disadvantages is they are slower than repeaters because they do the filtering. So there is some decision making which is going to create delay. So they are slower than repeaters. They do not filter broadcast. If a broadcast frame or broadcast packet has been received, they will broadcast it. They won't filter the broadcast. We will see later on there is broadcast, there is multicast, there is unicast. Later on you will learn. It is more expensive than repeaters. These are the disadvantages of bridges. Now switch. Switch operates at like there are two layer switches or there are three layer switches. Means they will operate at physical layer and data link. And three layer means they will include network layer also. So that means that switch, three layer switch will act as a router. Okay? It will have the functionalities of the router. So it can act as a network and it can transmit the packets. And the two layer switch will act as a physical layer and data link layer, and it will act like a bridge. So bridge is an example of two layer switch. Bridge with few ports can connect few LANs, and bridge with many ports may be able to allocate a unique port to each station, with each station on its own independent, own independent entity. So there is no competing traffic, there is no collision. Three layer switch is like a router. We have already seen like three layer switch. That switch will have the capacity of router. So router, what is the function? Router works at network layer, which will handle packets. When you have a data link layer, it will be frames. When you have talk about network layer, it will be in a packets. So at packet, you have logical address. See, MAC address is a physical address, okay, which is there in the NIC. And logical address means the IP address, okay, which can be changed. You must have like seen that IP address which is given to that particular node which is connected in the network. It can be fixed or it can be dynamic. It can be changed. See, that's why that is called as a logical address. But MAC address, when you have a network interface card in the piece in that particular node, the MAC address won't change. That is common or that is permanent for that particular PC. The router normally connects LANs and WANs in the internet, and it has a routing table for decision making, deciding which route to take. And routing tables are dynamic because, as we know, that the nodes can come in and go out of the network. They will keep on connecting and disconnecting to the network. So the routing tables have to be updated. There are different routing protocols which are used to update the routing tables. Okay. So these all functionalities will be included in a three-layer switch. When that switch acts as a router, all these things are needed. But when the switch is a two-layer device, it is restricted to the data link layer. It handles only the physical layer. Okay. So routers are connecting LANs and WANs. So this is a WAN. Through WAN, you have connected different LANs. So this is a router. Advantages and disadvantages of routers. Uh, Advantages is like a three-layer switch or a router only. So they provide the sophisticated routing, flow control, traffic isolation. They can be configured. So network manager can they have different policies based on the routing decisions. They allow active loops so that redundant paths are available. Disadvantages is they're protocol dependent devices that must understand the protocol they are forwarding. They can require considerable amount of initial configuration. and they're relatively complex devices and generally more expensive than bridges. So this is like routers versus bridges. Routers are explicitly addressed, but bridges are implicitly addressed. Vulnerabilities. Routers can handle failures in links, stations, and other routes, but bridges use only source and destination MAC addresses, which does not guarantee delivery of text. So, basically, these concepts like how they are explicitly addressed, what is addressing, what is the failures, and all. You just remember at this point these things because voice breaking. Uh, Still, it is breaking.
No, ma'am.
Yeah. So these things now basically be more clear when we will learn or when we will study that entire layer. That is when you will come to know the actual functionality of the data link layer, how it functions, how what is the role of this bridge, what is the role of this router, how they are routing. There are various routing algorithms. That time all these things will become more clear that how they are handling the failures, how the source and destination MAC address is used for the delivery of the frames. The message size is like there will be for fragmentation of packets. Uh, it's like say when you talk about routers, you have different networks connected. Here you can see this is the diagram for router. So when you are in WAN, okay, this is a wide area network. You have different LANs. This network can handle a packet size. There will be some different uh, transmission mediums used, different transmission technologies used. So this particular network can handle, say, for example, 1 MB packet size at a time. And this particular network may handle 2 MB packet size at a time. So in that case, whenever you are transmitting here 1 MB packet can be transmitted as it is. But when this 2 MB packet comes over here, it has to be broken down to two 1 MB packets because this can handle only 1 MB. So this is the function of the router to do the fragmentation and again reassembling of the particular packets. So this can be done. This can be performed message size according to whatever is the that network particular network supports. Accordingly, the fragmentation of the packets and actually handling of the different packet different sized packets is done by the router. Routers cannot fragment. They cannot fragment. They can just forward the frame as it is. Okay. And when the frame is too big for the next NAN, they will not forward. If the fragmentation is not done at the bridge, routers have the routing, they take the forwarding decision. There are different routing algorithms to so that they can forward that particular packet to the specific destination. And bridges just forward a message to the outgoing network. So that bridge just forwards that particular frame according to the MAC address. They don't work at logical address. Okay, so they don't work at logical address. Next is the priorities. The routers can treat packets according to the priorities, but bridges can treat all the packets equally. Priority we will see later on, like at routers, like basically routers handle packets. And for packets, you use IP, that is Internet Protocols. And in IP, you will see there is a every layer have their header and footer added. So they have the priority. That is, if you want to have the packet to be transmitted with the highest priority, that packet will be given highest priority and transmitted first. Suppose there is a queue built at the router, there are 10 packets arrived. Then the highest priority packet will be transmitted first, or it will be transmitted with less propagation delay. So there can be a priority given to the packets, but since bridges handle frames, there is no priority given to the frames. Okay, all the frames will be treated in the same manner. Error rate is there is a error checking. There are different error checking algorithms. There are different parameters which are checked, and the received packet is examined. So error rate is less. But in Mac layer, it provides very low undetected bit error rate. So it also has different error correcting or error detecting protocols used, but still at Mac layer, it is providing the error detection provided is very low compared to the network layer. Security is they both provide the ability to put security walls around specific stations. They generally provide greater security than bridges because they can be addressed directly, and they use additional data for implementing security. There is a concept of bridging routers, which is routers. They combine the features of bridge and router. They are capable of establishing a bridge between two networks as well as routing some messages from the bridge networks to other networks, and they are sometimes called as layer 2 by 3 switches and are combination of bridge and router hardware and software. The next is the gateways. Gateways is generally you interchangeably. They generally work at transport layer, and you use the like they interchangeably you use the term as routers and gateways. They connect two networks above the network layer of OSI model. So gateways generally work at transport layer. They are capable of converting data frames and network protocols into the format needed by another network. So basically, gateways are um, where they are used is you can see over here. So for example, when you are using WANs, okay, over here they are above network layer, so they talk in terms of packets, or they are at the transport layer. So basically where this particular thing is needed is, say for example, we have seen this network will have its own transmission technology implemented, and this network will have its own transmission technology implemented. If you take the example, say for example, this WAN is of we know WAN is what? Wide area network, which is expanding over the continents, okay, across the countries. So this country will have its own transmission technology, like it will have its own standards which are implemented, network standards implemented. This will have its own network standards implemented. The technology used will be maybe different across the two countries, okay, but they have to be compatible. That compatibility is provided through gateways. Okay, maybe it is a hardware or software. So generally, say for example, when you are sending the emails, okay, this will have some different standards. They will have some different technology which is used at the above layers, and this may have its own various standards of transmission of data in the above layers of the network. Okay, so gateways will provide that. They are like the softwares which will provide you the compatibility between these two different kind of technologies. Okay, so they are capable of converting data frames and network protocols into the format needed by another network. So there may be a different format. We have seen that there is different kind of message size. So two different networks may handle different size of messages, different size of packets. They packets may be transmitted They may be transmitted through different type of transmission mediums which support different type of technologies. There are a number of things they provide for translation services between different computer protocols. So different protocols may be used across different countries. Like there are different standards which are followed, okay, for every country. So you require some kind of translation services for that particular data. So this translation between different or the services, translation services between different protocols is provided by the gateways. Now there are two types. You have transport gateways. Transport gateways will connect with the two networks at the transport layer and application gateways at the application layer. So depending upon what kind of translation service is needed by that particular network. So accordingly, different type of gateways will be used. So application gateways connect two parts of an application in the application layer. For example, sending email between two machines using different mail formats. So they are broadband modem router is one example of gateway. So which kind of underlying technology is used? So different kind of networks basically are connected. Different standards are followed in different countries. So gateways are useful or they are used for connecting these two different kind of networks. So we have the as you are like we have seen different layers are having different functions, different services are provided, and accordingly you require different devices to provide those services. Okay, network devices are used. Basically, they are the actual devices which are doing this particular functioning. Okay, when you say data link layer, how data link layer is implemented, that like link layer function is done using the link layer devices only. So these devices are there which are connecting these networks and which are performing certain functions for that particular layer. Then there was one more point like switch. So switch is basically a multi-port bridge only. It will have the difference between like it has a buffering capacity, that is you can have the queue, okay, design, and it can have the large number of ports, uh, and it can expand like the performance. Again, it is a data link layer device and it can perform error checking before the forwarding of the data, so it is more efficient so that it won't forward the packets which are having errors. Later on we will see there is again concept of collision domain and broadcast domain in the case of switches and how it divides the collision domain, that we will see later on. There is a network interface card we have already seen. It's like a network adapter, okay, that is used to connect the computer to the network. So it is installed in the computer for establishing a LAN. It is having unique ID, which is called as we call it as a we have a MAC address. So this is about different networking devices. Uh, is there ये क्या लिखा है? I couldn't see this. No, Shivam Gupta. I was audible. Have you understood the concept of network devices? Is there any problem?
No, ma'am, no problem.
I'm sorry, I couldn't see this. Priyanka's message voice is still breaking. Okay.
Ma'am,
अगर मैं
back then it was breaking, but afterwards it was fine.
it was fine. So you could hear the lecture, no? It is
Yes, ma'am, no problem.
no problem, no? Yeah, yeah. And I'm sorry if I don't see the messages, no? You just unmute yourself and you can speak, okay? Like whatever is the problem.
Yes, ma'am.
Okay, so yeah. So is anybody having any doubts in this particular topic of network devices? No. Okay. Okay, so according to your syllabus, uh, we have completed the from first module. We have completed the topics like uh, you have LAN, MAN, WAN. You have different network topologies. Now, applications of computer networks. I think it is very uh, easy. Like there are a number of applications, and you can always, uh, that computer networks are used in many fields. Okay, like it's like everywhere you will find the application of computer networks. So you can just name in various organizations it is there. In e-commerce, your daily uses, you are having education field, all the companies, e-commerce is there. Uh, Everywhere you are having the applications of computer networks. In health industry, nowadays you are having this IoT and all. You are using all these things using the networks only. So you can just name those applications. Then there was next is like protocols and standards need for layered protocol architecture, OSI reference model. We've completed that. We have completed TCP/IP architecture, protocol suite, comparison of OSI and TCP/IP. We have completed with the network devices, various network devices. Okay, and a small part like addressing is remaining. We have just named those terms like physical address, logical address, port address. There is concept of socket addressing. That small part of addressing is only remaining from module 1. Okay, then your module 1 will complete. The next is the physical layer, which is having actual transmission mediums which will be used. Okay. And before starting with the next topic, I would just like to know what was there. Like you had lab yesterday.
No.
No, ma'am.
No, ma'am.
Zainab ma'am was supposed to take the lab, no? Yesterday.
Yeah, ma'am. We didn't got any response.
Just 1 minute. Just 1 minute. 1 minute. Yeah. Just yeah. What somebody was telling something. Hello.
Ma'am, she did not take. Like we asked, but then she replied with a no. It's not there. Okay.
Okay. Actually, previously she was supposed to take the CCN lab, and now I will be continuing with the CCN lab. But yesterday's lab was supposed to be taken. Okay, no problem. We will continue. Like next week onwards, I will only take your practicals. Okay. Now Zena ma'am is not going to take your practicals. Okay, but I was been told that she will be taking to yesterday. That's why I have not taken. Otherwise, I would have taken your lab yesterday. Okay, no problem. We will be able to complete. No worries. Um, okay, so next week onwards, I will be taking your lab. So at that point, we will discuss whatever is the syllabus which we will be covering in the lab and all that we will see later on. Okay. So I was under the impression she has taken yesterday. Okay, no problem. Okay, so now we'll just have the brief uh, introduction about the physical layer transmission mediums. What all transmission mediums you know? First, you tell me. Okay, you can tell me what all transmission mediums you know. Hello. There are wired mediums. There are wireless mediums. Which wired medium you have seen? आपके computers कैसे connected होते हैं?
Cable,
Which wire is used? Cables. Which type of cables are used?
coaxial,
Coaxial cable. Okay. Any other type of transmission mediums
twist,
you are
twist,
huh?
twisted pair cable, ma'am.
Twisted pair cable. Okay. Or
Optical fiber.
Optical fibers,
Radio
yes.
waves, microwaves,
Okay.
radio wave.
और अच्छा, कोएक्शियल केबल्स आपने कहाँ पे देखा है? विच डिवाइसेस आर कनेक्टेड थ्रू कोएक्शियल केबल? कहाँ से कहाँ कोएक्शियल केबल आप यूज करते हो?
मैम पुराने टीवी में आते थे।
पुराने टीवी में आते थे। ओके। अभी अभी लैन में आप कैसे कनेक्ट करते हो? एक पीसी दूसरे पीसी से कैसे कनेक्ट होता है? Whenever you are using hub or
मैम
switch to
इथरनेट केबल से
Ethernet cable से।
RJ45।
That is a connector ना?
यस मैम।
हाँ। ऑप्टिकल फाइबर्स कहाँ यूज होते हैं?
मैम हमारे लोकल ISP यूज करते हैं हाई स्पीड डेटा ट्रांसफर के लिए।
ओके। एंड ट्विस्टेड पेयर कहाँ यूज होता है?
नॉर्मल लैन उसके लैन वायर में।
मतलब कहाँ पे? सी यू हैव अ ट्रांसमीटर, आपका एक पीसी है, आप कहीं और आपके
Ma'am,
फ्रेंड
to
से
connect
कम्युनिकेट
the PC to router.
पीसी टू राउटर कौन सा
Yes.
वायर यूज होता है?
Ma'am, Cat6, Cat5, Cat5e.
ओके। और
Yes, ma'am.
मैम
उसके बाद?
मैम अपन टेलीफोन में ये ट्विस्टेड पेयर यूज करते हैं ना?
हाँ।
ओके मैम, थैंक यू।
Okay, so there are different kind of transmission mediums, wired and wireless. And whenever you are communicating, the user one is communicating with user two. There are different kind of transmission mediums which the data comes across. Like when you are transmitting data, the user is not aware. अभी जैसे मैं आपके साथ जब भी कम्युनिकेट कर रही हूँ, माई पीसी इज कनेक्टेड टू द नेटवर्क, थ्रू दैट नेटवर्क टू some, like there are in between there are different kind of transmission mediums which are used, not a single transmission medium. Okay, so there are various transmission mediums which are used in computer networks. So your next module is physical layer, which comprises of different kind of transmission medias which are used. And we have already seen the physical layer devices. So that will be covered in the next. I think I will start within the next lecture only. I will take attendance now. Okay. So I'll just take the names from the students who are present in the meet. Okay. तो वो अगर present है, क्योंकि कैसे कैसे होता है ना, like अभी I am new to your class, but still I have taken 4 lectures. Okay. So there are some students जो join होके they are left. So उनका नाम जो है वो meet attendance में रहता है. But if you see the duration, they have just come in for 2 or 3 minutes. तो सिर्फ मैं मीट अटेंडेंस लूंगी ना तो मुझे वो बहुत सारे नाम मिल जाते हैं। तो ऐसे कभी कभी ऐसे होता है, अभी ऐसे 2-3 नाम ऐसे हुए हैं जो दे हैव जस्ट जॉइंड फॉर सम फ्यू सेकेंड्स और फॉर सम फ्यू मिनट्स, Till last lecture, I have given attendance for a student who have joined for half an hour also. Okay, लेकिन अभी हर बार ऐसा नहीं होगा. If that thing continues with the same student, he is just joining half an hour late, he is there, and then he is leaving at the time of like end में, या फिर वो starting में join हो रहा है और फिर half an hour के बाद he has left. If you're having any network issue and because of that you are left, you can just inform it in the WhatsApp group. मैं WhatsApp group पे हम लोग है. You can inform me personally, not necessary कि सब लोगों को पता चले. You can just, if you have any network issue kind of thing, and then because of that you are left and you cannot rejoin. Okay, you can always inform. But अगर आपका अटेंडेंस हाफ एन आवर के लिए ही होता है या 15 मिनट के लिए है, 10 मिनट के लिए है, तो एवरी टाइम you won't get the attendance. Okay, is that clear to all the students? Okay, अभी के जितने लेक्चर्स हुए हैं ना मैंने दिया है, बट देन आई हैव सीन दैट पैटर्न. तो ऐसा हमेशा नहीं होगा कि आधे घंटे के लिए आपको पूरे लेक्चर, आधा घंटा भी ठीक है. कुछ कुछ बच्चे हैं 5 मिनट, 7 मिनट, 10 मिनट, 15 मिनट. तो 15 मिनट्स के अगर आधा घंटा है तो ठीक है, लेकिन 15 मिनट्स एंड एवरी टाइम आधा घंटा इज नॉट ओके. एवरी टाइम यू आर कमिंग लेट, इट्स लाइक कमिंग लेट टू द क्लास एवरी टाइम. ओके, तो ये हमेशा नहीं होगा. So I will just take the roll call, those who are present in the meet list, and accordingly I will give the attendance. Okay, roll number 3.
Yes, ma'am.
Yeah, and if somebody is having any mic issue, Priyanka, you are there. If somebody is writing in the chat box, you will inform me.
Okay, ma'am. Okay.
Yeah. So roll number, I think I can see 3, 4, 5, 6, 7. Roll number 3. 3 is already.
Yes, ma'am.
Yeah. 4,
Yes, ma'am.
5,
Yes, ma'am.
6. Roll number 6,
Present, ma'am.
7,
Present, ma'am. 9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12 is not there, I think. 13,
Present, ma'am.
14,
Present, ma'am.
15, 15, not there. Okay. मैं पूरा नंबर ले लेती हूँ. आई विल चेक द अटेंडेंस आफ्टरवर्ड्स, क्योंकि मुझे ट्रांजैक्शन बहुत ज़्यादा टाइम ले रहा है. 15 is not there. 16,
Present, ma'am.
17, 18,
Present, miss.
19, 20, 19, 20 कोई नहीं. 21, 22, हेलो, am I audible? Okay, कोई
Yes,
है
ma'am.
ही नहीं है. बस सीधा 23 है. Okay, 23, 23, roll number 23, 24, Yeah, I can see them in the meet. 23, 24 नहीं है. 26, Rumil.
Ma'am, he is written there.
Who?
Drumil.
Drumil has written in the chat box. Okay. ये 23, 24 कोई है नहीं. Okay, 26 is there. Okay. 27, 28.